Bismillahirrahmanirrahim. Hello everyone. I hope you are all doing well. I welcome you all to the class of real analysis. Our discussion is continue on properties of supremum and infimum of a set. I hope you have a clear understanding of supremum and infimum of a set. Bismillahirrahmanirrahim. Hello everyone. I hope you are all doing well. I welcome you all to the class of real analysis. Our discussion is continue on properties of supremum and infimum of a set. I hope you have a clear understanding of supremum and upper bound of a set. So in today's lecture, we will discuss the next property of supremum that is related to the supremum of a set. So this is the property number 4. In this property, we have to show if S is a non-empty subset of R that is bounded above. S is a non-empty subset of R that is bounded above. It means it have upper bound. And let A be any positive real number. A is any positive real number. Now we define a new set that is the AS, which is actually the product of elements of set S with a real number A. Then prove that supremum of AS is equal to A times supremum of S. Mean to say, when we apply supremum of this set, then it will be the product of the real number and the supremum of set S. We can verify this property firstly by an example. Suppose our set S is simply the first 10 natural numbers. What is the supremum of this set S? The supremum of set S is 10. You know, the supremum is a least upper bound, and the least upper bound is an element which is always greater than or equal to all elements of the set. So supremum of set S 10. We fix A is equal to 3. Let A is equal to 3. Now we make a new set AS, that is here 3S. So multiply each element of set S with 3. We have 3, 3 to the 6, 3 3 the 9. Last element will be 30. Now what is the supremum of 3S? The supremum of 3S is equal to 30. Whereas the right hand side of which is A times supremum of S. What is A? A is 3 and supremum of S is 10, which is equal to 30. So we can see that this property is verified by this particular example. So now we prove this property in journal. It is given that S is non-empty, set S is subset of R, and S is bounded above. So if S is bounded above, so S has an upper bound in R. Further, since R is complete order field, so by definition of complete order field, supremum of S exists in R. Let supremum of S is equal to U. Now we will show that supremum of AS is equal to AU. Supremum of AS is equal to AU. Our property says that we have to show supremum of AS is equal to A times supremum of S. We suppose that supremum of S is equal to U. So supremum of AS is equal to AU. This is our target to show. Now what does this expression 1 shows? Supremum of S is equal to, what does this expression shows? Supremum of AS is equal to AU. This expression shows that AU is the least upper bound of set AS. So this is our target, final target, that we will show AU is the least upper bound of the set AS. Okay. Now we use the definition of the supremum of S in expression number 1. In equation number 1, U is the supremum of S. If U is the supremum of S, then U is greater than or equal to every element of set S. The set elements of set S are the small s. So U is greater than or equal to S. Now we convert this expression, this inequality, in form of AU. So multiply inequality number 1 with A. On both sides we have so by multiply A greater than 0 on both sides of 1, we have AU is greater than or equal to AS. Further, now from inequality number 2, the element AS belong to the set AS. This is the set AS. If as AS is any arbitrary element of this set AS, if AU is greater than or equal to every element AS, then AU is an upper bound of set AS. Since AS is an element of set AS, so 2 shows that AU is an upper bound of set AS. Next we shall show that AU is the least upper bound of AS. That was our final target. In the start, we have to show that AU is the least upper bound of set AS. So AU is the least upper bound of set AS. This is our target. How we will show this AU is the least upper bound? We suppose there is an other upper bound V, which is greater than this upper bound. Then in this case we say AU will be least upper bound. So now let V belong to R is another upper bound of set AS. Then AS is less than or equal to V. How? Because V is any real number and V is an upper bound of AS. So the definition of upper bound says that V is an element which is greater than or equal to every element of set AS. So every element of set AS is less than or equal to V. Further, we convert this inequality for the elements of set S. For this, we multiply on both sides by 1 by A, or in other words, we divide this inequality by A on both sides. So this expression will convert to S less than or equal to 1 by AB. Since S is an element of set S, this shows that this expression shows that every element of set S is less than or equal to this element 1 over AB. This shows 1 over AB is an upper bound of set S now. So 3 shows that 1 over AB is an upper bound of set S. We know that least upper bound is always less than or equal to upper bound of set. Least upper bound of a set is always less than or equal to upper bound of set. So what is the least upper bound of here? Here 1 over AB is an upper bound. So this is greater than or equal to supremum. Least upper bound means supremum. What is the supremum of S? Supremum of S is U. So U is less than or equal to 1 over AB. 1 over AB is an upper bound of set S, while U is a least upper bound of set S. Least upper bound of set S is always less than or equal to upper bound of set S. So U is less than or equal to 1 over AB. Multiply on both sides with A, we have AU is less than or equal to V. 4 shows that AU is the least upper bound of set AS. That is our target. AU is the least upper bound of the set AS. This implies supremum of AS is equal to AU. Supremum means least upper bound. So the supremum of AS is equal to AU, and finally U is, because since U is equal to supremum of S, so supremum of AS is equal to A times supremum of S. I hope today's lecture is helpful for you, and now you have clear understanding. If you have any doubt, any query or question, you can comments me. Inshallah, I will reply you. See you in the next lecture. Take care. Allah Hafiz.